Learn how to solve equations with variables on both sides. Let's start by reviewing how we solve these types of equations. In the first example, you will start by distributing the 2 to both terms inside the parentheses, giving you 2c minus 12 equals 9c plus 2. Our next step is to get both terms with c's on the same side of the equation. To do that, we're going to subtract the entire term 2c from both sides. This will cancel out the c on the left side and give us 7c on the right side of the equation. Once you get all of your c terms combined on one side, you can solve the equation as a regular two-step equation for an answer of -2 equals c. In our second example, you can start by adding 6d to both sides to get all the d terms on the right-hand side, or you could subtract 2d from both sides. I tend to choose the option that will keep my variable positive, but if we do that in this case, we end up with nothing left on the left-hand side of the equation. If that happens, you can hold the place value of the left-hand side of the equation with the number 0. Then you would solve the equation by subtracting 4 and finally dividing both sides by 8 for an answer of -1/2. Let's take a look at some other special case scenarios that might occur. If you look at these equations, initially they appear to be the same as or similar to the ones we just looked at. However, when you start to solve them, you notice some interesting things that happen. For example, when you distribute the 2, you end up with 10 minus 8a on the left and 10 minus 8a on the right. Sometimes as you're going through the equation, you might not even recognize that that appears to be a little unusual. So if you are trying to get all of the a's on one side, you then might notice at the next step that when you do that, the a's are going to cancel out on both sides of the equation, leaving you with something that looks like this. In this other example, if you start by combining the m terms on the right side of the equation, you're going to get 6m minus 5 equals 6m plus 7. Again, you might try to continue solving as normal, and then notice that, oh, both of my 6m's cancel out on both sides, leaving me with an answer of -5 equals 7. When we get these two scenarios that occur, we have to decide what does that mean for our equation and our variables. This example on the left tells us that when we have 10 equals 10, that any value of a will give an equation that is equal on both sides. This is true for any solution. So this equation has what we call infinite solutions. This is also sometimes called an identity, which means that the equation has infinite solutions. You can write either answer. On the right-hand side, when you see -5 equals 7, that is something that is never going to be true. So that means that there is not ever any value for m that will make this equation equal. So we say that this equation has no solution. It's impossible to solve. Now let's take a look at some word problem scenarios. When you're solving these, what I would like for you to do is to pause the video and go through and write defining your variables and then write your equations, and then unpause and check to make sure your equations are correct before solving them. In this first example, you should let X equal the number of bottles that the hairdressers are purchasing from company either A or B. Your equation would be 4x plus 10 equals 3x plus 25. When you solve that, you should get x equals 15 bottles. Another part of this question I want you to consider is if you sold less than 15 bottles, which company would be the better deal and why? In this case, if you sell under 15 bottles, company A would be the better deal because even though it's more per bottle, it has the lesser shipping or handling costs. So in this case, less than 15 bottles, company A is the better deal. If it's more than 15 bottles, then it would be the opposite, company B, because it's less per bottle and you've already exceeded that $25 handling fee from having sold those 15 bottles. This next example has a few different equations that you could write, or a few different ways you could write it, but you want to start by saying let X equals the amount invested is how I did it. I suppose you could do it as total amount, but I did X as the amount invested, and then I wrote it as half X plus 1/10 X plus 1/20 X plus 35,000 equals X. You could also do it as subtraction by starting with X and subtracting each of the fractions. This pen is not quite working too well, so I hope you can read this. Equals 35,000. Your final answer for the amount invested here is 65,000. Our third example has no let statement, but since we are given the expressions for angles 1 and 3, and those are vertical angles, we know that they are always equal in size, so we would write our equation to show that they are equal. When you solve it, you will get x equals 12, and then you make sure you don't forget to plug that back in and find the measures of each of the angles in the picture, 1, 2, 3, and 4. This last example is a bit of a challenge, and what I want you to do here is give it your best attempt to write your let statement and write your equation, and we will check that example in class together tomorrow.